Hello and welcome to ISO images and link triggers, the 16th video as part of our Red Team Fundamentals mini-series. In the last few videos, we have been discussing the concept of phishing and payload delivery. Up until now, we've not actually developed a functioning payload that, once executed, would grant us a session to our command and control infrastructure. As the goal of many Red Team assessments is to compromise a network, payload execution is amongst one of the most important phases of an assessment as it serves as the entry point to it. In this video, we will be discussing a particular technique through the use of containerization and link triggers that can help us achieve this. And as per usual, everything we teach in this video is purely for educational purposes. We take no responsibility for your actions. Now, one of the oldest means of distributing software was through the use of optical discs. And if you're old enough, you might recall going into a computer shop to buy a copy of a game or a product such as Microsoft Office. You would buy a digital copy of an optical disc, insert it into your computer's disk slot and install the product. ISO images are essentially the same as optical discs, however, they have been modernized to function without requiring a physical disk copy. Much like their physical counterparts, these images could be used to include installation files, programs and various other data. Now, you may wonder, why are we discussing such antediluvian technology? Well, since ISO images have been ported using their traditional file system format, these containers are not based on NTFS. And if you've watched our previous video, Mark of the Web only applies for files that are NTFS based, which means that technically ISO images should not be able to support it, and thus not apply it for the payloads that we may be distributing. Now, there is an important caveat with this. Given the rise of payload delivery through ISO image containerization, Microsoft has taken precaution to apply Mark of the Web metadata to such files when distributed over the internet. More specifically, this was addressed with CVE 2022 41091, which has started applying Mark of the Web metadata to such files. However, there is a technique where we can leverage ISO containers and still be able to bypass Mark of the Web restrictions if we structure our phishing pretext correctly, and we will take a look at how we can implement this shortly. For now though, let's take a look at PackMyPayload, a tool that we can use to create ISO images amongst other containerized payloads. So you can find PackMyPayload on GitHub, and I'll leave a link to it in the description below. And basically it is a tool used for creating containerized payloads. And you'll find some description about this tool, some background why this tool was created, and some use cases of how malware is leveraging these containerized payloads to distribute malware. But what we are interested in is the features table. Now, the features table essentially outlines all of the tools supported containerization formats. So you can see here we've got zip, we've got 7-zip, we've got ISO. We've also got CAB and VHD files. And then it also outlines whether the specific format strips Mark of the Web metadata, whether it provides off-the-shelf Windows support, so that is whether Windows supports it by default, whether the file format requires elevation of privilege. That means whether administrative access is required to extract the files that may be packed within it. And then also a remarks column, which basically outlines any useful information that you should know with the format. So for instance, Mark of the Web within the zip format is only stripped with a specific CVE. Now, what we are going to be interested in is ISOs. And as you can see, it has the most minimal requirements needed. And it provides us with great flexibility in how we deliver payloads. Okay, so enough with the blabber. What I'm going to do here is I'm going to use a git clone to clone the repository. And once cloned, I'm going to cd into it. And then using the virtual env command, I'm going to set up a Python virtual environment. Okay, and now we're going to need to activate it. And once activated, we can use pip3 with the install argument and the R switch to specify the requirements file, which essentially contains the dependencies of the tool. Okay, so that should be installed. So let's just ensure everything is working correctly. And as you can see, we get valid output that outlines the tool's basic help menu. Now, before we actually deliver the ISO container, we are going to need a payload that will be executed by the target victim. Now, you can be as creative as you want here, but to keep things simple, we are going to use Sliver. And if you're not really sure how to use Sliver for the generation of payloads, we've made a video about Sliver in the past, and I'll leave a link to it in the description below where you can check it out. But essentially, we are are going to use the generate command, and I'm going to generate a beacon. And then I'm going to specify the B switch, which will specify that the implant is using the HTTP protocol to communicate back to the C2 server. So we're going to need to provide it the host name of the C2 server. Now, optionally, you can specify the time in seconds for which the implant will communicate back to the C2 server. So in our case, we will specify 30, and keep in mind by default it is 60. And then also we can specify a custom jitter rate, and this specifies a random interval in addition to the existing time that the implant will wait before reaching out to the server. So I'm just going to specify a jitter rate of 15 seconds. Okay, so last that remains is just simply specifying where we will save our payload. And once done, we can simply select enter, and our payload or the payload's generation should begin. Okay, so with the payload generated, you're going to want to make sure that a job is running that will handle the communication. Now, in our case, I have already set up a job, but in the case of HTTP, you will simply run the HTTP command. Now, in order to pack our payload within an ISO container using PackMyPayload, we will have to specify several key arguments. Now, if you're not sure how to use the payload, you can simply use PackMyPayload with the H switch, which will print out all of its supported command line switches. But to keep things simple, we only need to specify the path to the payload that we previously generated, and then also the name of the container. So I'm just going to use payload.iso. Now keep in mind that, the extension you use will depend on the containerization medium you want to use. So in our case, as we are distributing payloads in an ISO container format, we are using the extension of ISO. Now, in the case you were using zip, you'd simply use zip, or 7-zip for 7-zip. But as this video is on ISO, we are going to use ISO. Okay, so let's select enter here. And as you can see, PackMyPayload has successfully managed to generate and write our payload into our ISO image. And this was stored within the same folder where we executed PackMyPayload. All right, so it's ready to be shipped to the victim. Now, in our case, I'm not actually going to show you the process of delivering the payload through an email, but let's just assume that we delivered the payload using a convincing enough phishing pretext. Okay, so once the victim downloads the ISO image, and once the download completes, if we attempt to double click on this image file, you will notice that an additional smart screen prompt is raised. Now remember, this happens because mark of the web is still applied for ISO images that are delivered over the internet. And we can actually confirm this by selecting properties. You'll see the security attribute indicates that the file has indeed originated from the internet. And in order to actually run it without smart screen prompting the victim, they would have to manually unblock it. Now, obviously, they can double click this, select open, which will remove mark of the web. And now this is the important point, that if the victim attempts to run the payload that we delivered through the ISO image, another smart screen prompt will raise. Now, more specifically, this smart screen prompt relates to the file not having a valid digital signature, and therefore smart screen could not verify its publisher. So again, keep in mind, if we attempt to run the executable within the mounted ISO image, another smart screen prompt will raise. So that's 2 now. However, an interesting thing happens when we download the ISO image and once again attempt to mount it. And now if we actually take the implant and move it to another directory anywhere in the system, and then go into that directory and execute it from there, you will notice that the mark of the web, or the smart screen prompt that was previously raised, is no longer raised. So where we previously saw that an unknown publisher prompt was raised, the prompt is no longer raised because we effectively managed to bypass mark of the web. And we did this simply by moving a file to another directory on the system. And now if we can build pretexts to essentially persuade our victims to move a file into another directory before executing them, we can theoretically and practically bypass mark of the web. So this is still a useful technique today, and it's still leveraged. And as far as I'm aware, this has not yet been patched or addressed. And if we actually take a look at the task manager here, go and find slow deputy. Oh, I saw it there. There we go. You'll see that the process is indeed running. Now, one of the issues with the conventional techniques of simply placing our implant payload within the ISO image is that it is very sloppy and most certainly unconvincing. Using EXEs and other file formats that allow direct execution of payloads is old school, and we can achieve better results through the use of customized link triggers. A link trigger is the name given to shell links, which are essentially shortcuts within the Windows operating system. These shortcuts function as various references throughout the system to things like files, folders, network locations, etc. Essentially, they provide us with the ability to access desired items without having to navigate through the file system to locate their original resource. And from a red team perspective, shell links can be extensively customized to include custom icons, descriptions, and most importantly, they are capable of executing system commands. Therefore, through these customization capabilities and their various chaining techniques, we can customize shell links to appear as legitimate files, whilst actually redirecting to different content stored elsewhere on disk and executing our desired actions in the background. So with the fundamentals understood, let's get our hands dirty with actually generating some link triggers of our own and improving our payload execution methods. So the tool that we will be using to generate link triggers or to generate shortcuts will be PyLnk. And if we scroll down here a little, you'll be able to see all of its features, some examples of generating some link triggers, and some historical changes made. So let's take the GitHub repository here and use git clone to clone it. Then I'll cd into it, and then use the virtual env command to set up a virtual environment. And then of course we will need to activate the virtual environment as well. Now, whenever you have a setup.py source file within the repository, you can simply just use pip install to install the dependencies. You don't actually need to run or install the requirements through the provided requirements file. And this approach is far more straightforward and less error prone as well. Okay, so let's install it. And once installed, we can simply run Python 3 with the PyLnk3.py source file, which will list the help options of the tool. Now, whenever we create a new link trigger, we will use the create argument, and we can use the H switch to view all of the command line switches that this argument supports. Now, you'll see here we have two positional arguments. We have the target, so this will be the program that is executed. And then also we have name, which will be the name that we give to our link trigger. Now, we can just use the positional arguments as specified, but we can also specify a set of arguments for the target. So in the case that we're using, say, CMD or PowerShell, we can supply it an additional set of arguments by using the arguments or a switch. Okay, so I am going to use the create argument, and for the path, I am going to specify the path of CMD. So I will be launching a new CMD process to essentially execute our payload. Okay, so this will make sense once we specify the A switch and the C switch for CMD, and then we will specify the name of our generated payload with Sliver that we will be running. So essentially, to break this down, what we are doing is we are launching a new CMD process to essentially launch our Sliver generated implant. Okay, and then lastly, we will also need to give it a name. We'll just name it trigger.link. Now, before we deliver the ISO image to the victim, we must ensure that both the implant and the link trigger is packaged within the same ISO image. And to do so, I am simply going to use the make dir command, make a new directory within payloads, and then I'm going to move the slow deputy implant within that newly created directory, and the same applies for the link trigger. Okay, so let's just ensure that everything is present within that directory. So we can now use Python 3 with the PackMyPayload.py script, and then we will specify the path of the folder that will include all of the items being packaged into the ISO image. And if you actually take a look at the output of the command, you'll see that both our files were successfully packaged. Okay, and from the perspective of the victim, they are going to download the ISO image again. If we go into our directory, open up the ISO image container. So now you'll see we have two files. We have the link trigger, and also we have the Sliver implant. And the Sliver implant will be launched by running the link trigger. So we can actually inspect the contents of the command line that will be executed. So you'll see here in the target section, we have C Windows System 32 CMD, and then it's also passing for its command line arguments the implant that is being executed. And keep in mind that this is relative to the path from where the link trigger is being executed from. Okay, so if we attempt to run this trigger now, select open, you'll see that a new command line prompt is opened up. And if we go back into our task manager here, scroll down here a little, you'll see that indeed our implant executed. Now, before we discuss the final option that I want to showcase in where we can hide our implants by using link triggers, we can actually extensively customize them. So we can include a description, we can include an icon, we can include an icon index, a working directory, and the mode in which the implant will be executed. So whether its window will be maximized, normal, or minimized. So I suggest that you take a look at these options and experiment on your own on how much you can actually achieve with link triggers. And whilst we won't get into this much, we actually have a mini course that we released previous month where we discussed several initial access techniques, which includes how you can customize link triggers. So if you're interested in that, I'll leave a link to it down in the description below. Okay, so as you will recall, the way that we generated our ISO images included both the implant and the link trigger. Now, interestingly enough, by using PackMyPayload, we can actually hide certain files by using the H switch. And when a file is hidden, it will obviously be hidden from the user's perspective. The file that we want to hide is going to be our Sliver implant. And if we rerun this command again, you'll notice an additional line of output that specifies the file or the implant has been hidden. Okay, so for this to make more sense, let's actually deliver the ISO image to the victim. Okay, so back from the victim's perspective, they are going to download the ISO image, and once downloaded, they will mount it. And then notice now the Sliver implant is hidden, and it appears as if we've not even included it at all. Now, this is a Windows capability, and we can actually view more on this by selecting options here, view and show hidden files, folders, and drives. So if we apply this, you'll see that the implant or the executable is blurred out a little bit here or grayed out. So it is indeed included, but it has the hidden property, which makes it appear as if it's not. And the don't show hidden files, folders, or drives option is enabled by default on all Windows installations, which means that if we hide our implants, we have a higher rate of success in our implant's execution, because when the link trigger runs again, select open here, you'll see that our payload does indeed execute. And we can confirm this within Task Manager, scrolling down here a little. I believe I saw it, there we go, slow deputy. Now, PackMyPayload is extremely comprehensive, and I suggest that you take a look at some of the supported formats, some of the options that you can include when distributing or when delivering containerized payloads, and you'll be surprised by how much customization you can do through these containerization mediums and improve your payload delivery mechanisms. And we've discussed more about this particular technique in our mini course, which again is linked in the description below. And that will do it for link triggers and ISO images. I truly hope you found this video useful. Whilst the techniques we discussed are aging, they nonetheless provide an efficient means into a system, provided we have robust and evasive payloads. And although we've just covered ISO images, as I've said, similar techniques can be achieved through alternative containerization applications, and I suggest that you have a play around with PackMyPayload to discover them. That being said, our final initial access video will be based on FileFix. And it is one of the more common and powerful techniques today. But until then, feel free to join our Discord server, to which link you can find in the description below. There you can meet new people, chat to us, and soon participate in virtualized labs entirely through Discord, which we are sure you will like, and I hope to see you in the next one.